Hi all. So today's topic is on merge sort. This is a special one because here we are going to apply a new logic like divide and conquer. So it's divide and conquer. So here, as the name itself suggests, if you have a big problem, what you are going to do it, you are going to divide it into small pieces. You are going to apply your solution on these small pieces. And later, once this all small part of your question is fixed, then you are going to group this all to deliver the final output. Clear? So even in merge sort, like first, if we'll be having a list, let's say here we'll be having a list which is unsorted. We will be having random numbers, let's 5, 7, 10. Let's make it 17 and let's make it 2. So a random list which doesn't have which is not in sorted form. So what we'll be doing here is we'll break this entire list into small parts. So this can be broke, let's say, into 2 parts now. Here again, here the recursion concept itself comes handy. So if you are breaking this, here you can take 17 in left side. So here you will be first having 1, 5, 15 and 17. Okay, it's actually 5. Let me make it 15. And here you will be having, let's say, 10 and 2. Is this problem still like, can we still divide this? Yes, we can still divide this. So let's divide this. Then we have 1 and 15 here. We have 17 here. And what about here? Here, the problem can be broken into 2 parts that we have 10 and 2. Clear? And this can be again divided into 2 parts. So here we have 1, 15, 17, 10, and 2. Clear? So if you see this array which we have first divided it in such a way that now they are into a small pieces. We can't divide it further. So once you have done till here, so this is the one checkpoint we can say. So where we have divided the problem. So let me write it at top, the same thing which I have got here. So I have got 1, 15, then we have got 17, and then we have got 10 and 2. So these are in separate branch. So I'm going to add just a line here. Here you are. Once you are done with dividing, now your next task is to compare the logic. So what is the logic here? You want to arrange it in ascending format. Okay. So here now first you will get these and these 2 elements. So you will try to compare, one is less and then you will have 15. So you got a new array which has 1, 15. Then this was in a different branch. You will then compare this and this. So here it is 17. You will try to compare these 2. And here you will get to know that 17 is last. So when we try to club this both, the output will be something like 1, 15, 17. Clear? Now, once this is done, here the block is still there, still here. So you will compare these 2 items. You got to know from comparing that 2 is less. So you will place 2, 10. Okay. And for this and this will be compared at last here. And when we are comparing these 2, you got to know like 1 is from, you are going to take it from here. 2, you will take it from here because 2 is less. Then 15, 10, you are going to again take 10. Then again here from here, you are going to take 15 and 17. Clear? So this is on high level, like what we are going to do today. So let's try to solve it by step, and you will easily get to know like how we are going to approach it. So let's first write the function which will help us to divide, and later we can see how to compare and club it. Okay. Before that, we have to create an array. So let me create an array as int, let's say square brackets array equal to curly brackets. Inside this, I have to enter some random values. So let's say 12, 34, 33, 4, 5, 6, 78, 1, 2, 3. So some random values and then a colon, semicolon. Good. before doing before proceeding with our function, what we'll do, we'll create a method which will help us to display our array. Okay, otherwise every time we have to write our for loop, so that's not good. So let's write a function or a method which will help us to display our array. So let's write something as static void name. Okay, and here I have to display, let's say, change in word, and this will be display array. Okay, fine. What we are going to get the argument as, let's say, int square brackets array. Okay, fine. Now, after this, here we are going to write a for loop. I'm going to write for, let's say, int num colon array. So whatever array we get, curly brackets, enter. Here I am going to write south. It's actually a bit weird. So, what I can say is num plus a blank space, so there is a space in between. Yes. Clear? And let me go normal mode, delete this. Okay, this is our function which will display our array. Okay, let's go to the fourth line, for enter. Okay, let's go to the last one and let's add here semicolon. Okay, I am facing some error in this ID. I'm unable to install the Java server language. Otherwise, I would have received the error, like some errors if I do here, semicolon errors. It's possible to get this, but yeah, I'm getting some errors. So due to that reason, it's not done. And I don't want to shift to VS Code. So yeah, I have to deal with this until I fix this. Okay, cool. So after creating our array and after creating a display array function, now our turn is to let's display the array. So here I have to say call the function. So display array, and I have to pass the array, let's say ARR colon. So once this is done, now what I have to do is I have to call the function merge. Let's say merge sort, which we have not yet defined. So let me comment this. Comment this for a moment, and we'll come back to it later. Let's first define it. Let's say enter, enter, enter. Static. Okay. Next word and CIW. And here I'm going to say, let's say merge sort. Okay, fine. What we are going to get, we'll get an array. Okay, so in square brackets array. Cool. What else we'll get? We'll get let's say the starting point and the ending point. So instead of starting and ending, I'm going to say int left, comma, int right. Okay, so these are the two extra arguments that we are going to get. Okay, so what we did, we defined a function name as merge sort. We passed 3 arguments for it: array, left point, and the rightmost point. Now, what we are going to do in this, let's first find out the middle point, middle. Okay, what is this going to do? This will find the middle. You can do like right plus left divided by 2. Even that is possible. Okay, but in case if there are huge integer values, then that is going to create a mess, like it will create an error. So to avoid that thing, what we'll do is we'll first find the difference between right and left. So let's first find the difference. That is right minus left. Okay, so what this is going to do, this is going to give me the difference. I'll divide it by 2. So whatever I got, it's half I got. Now, after getting half, I'm going to just add it to my left. So left plus this. So this will also give me the midpoint. Okay. You can still use left plus right by 2. But if you are doing that, try to use for small numbers, like your array is short. So once this is done, I have to give a semicolon at last. So 3 top, and I have to just do this. Okay, got it there. And I have to put semicolon. So a semicolon. Okay, fine. So after this, we have not yet written our more the base condition, which we'll write because this is going to be a recursive call. Okay. So now once I found out the middle element, I need a function which is again going to divide it. Okay. So it's again the simple thing, merge sort. I'm going to call the same function. Okay. And here I'm going to pass the array, comma, the leftmost point will be same, left, comma, the rightmost point will be changed to middle. Okay. Did you get what I have done here? Initially, our original array is array, which is having left and right. So these are the full starting 0th point, and this is array length, we can say. Then here what I did is I found out the middle element. And how did I divide it? I called the same function where I passed the leftmost point, which is still the same point at present, that is 0. But the right point, which was the array length in the initial state, is now updated to the middle point. Clear? So again, this function will get called here. So this will be a recursive call. So it will keep on calling this, and it will go to its leftmost branch of our function, recursive function, right? Similarly, for our right branch or right recursive function, like what we have to do is we have to call the merge sort itself. Okay. We have to pass our array, comma, our rightmost part, like starting point will be changed. That will be whatever is my middle. As I have used middle up, so I can say middle plus 1. Okay. And then I can keep my right point as same. That is whatever is array dot length, whatever it will be. So that will be same. So what does this line does? This will sort my, not sort, this will divide. This will give me, it will keep on repeating again and again. At last, it will give me a single element. Clear? And what should be our base condition? As you see, we are continuously finding our left and right. So there will be a point where this will interchange, right? Where it may become like left is greater than right. Okay, so we have to avoid that situation. So here in 7th line, I'm going to say if so if left is less than right, then only do this. Otherwise, don't do anything. So let me just remove this and paste it after here. Yes. So what is my base condition? Until my left is less than right, that means we are having the correct arrays. We are dividing it properly, like keep on doing this. In case whenever my left is increased, how will it increase? Here I'm saying middle plus 1, right? So when we keep on finding, it will happen like this. So, okay. So this is my base condition. So what we did till now, we are able to just break our problem. We are just able to break our problem. Now, whatever the problem is break, now we have to merge it, right? Like we have to compare it and merge it. So for that, I'll create a new function or a new method. And where should I write this? I should write this inside this if condition itself. So let me write the function name merge. And what I'll pass is array. So what all we need to pass? We need to pass the array. This array is having the original position, okay, original values. This is not divided at. We have our original value. So to divide, what we'll be getting is the pointers, that is left and right. Those are the things which are getting reduced. So we need to pass our pointer, so that is left. We need to pass the middle as well as the right position. Why? Once we define our merge function, we will get to know why we are passing these things. Clear? So this completes the merge sort logic. Now the main logic is left, that is merge, the merge method. Let me write a semicolon here as well as the semicolon here. Okay, fine. Now, okay, now, so this is a decent checkpoint. What we have done, we have written a merge sort function, which will help us to break down our array into small pieces. But we have not yet defined our merge function, which will help us to compare these two arrays and club it. So let's do it now. So let's go to line number 6. So for that, I'll click 6, enter. Okay, 12 up arrow. Okay, it went up. And then I have to say insert mode, enter. Okay, I have to say static, enter. Escape mode, W. Okay, so the function name will be changed in Word. This will be merge. Okay, fine. What we are going to get is int square bracket array, comma, we'll get int leftmost point. Okay, comma, we'll get int our middle point, comma, we'll get our rightmost point, int right. Clear? Once we have got this thing, clear? Once we have got this thing, now we have to find out our left array and right array, right? So how will you find out what is our left array and right array? We are getting the pointers, that is left, right, and middle, right? So what we can do is first find out how much element is present in our leftmost array. So for that, I can create a variable, let's say int n1 equal to what my middle position, okay, minus the starting position. So what will this give? This will give me the length of my left array. Clear? And one more thing, I have to make a note that I am giving +1. Once this is done, the same thing I have to follow for my rightmost array. So that will be int n2. This is we are finding out the length. How will we find out the length? The last element, that is right. Okay, because right is greater than middle, right? So right minus middle will give me what? The length of rightmost element, the length of right array. Once I have got the length for both left array and right array, I'm going to create this array. So how will I create? I'll say int square brackets. Let's say the first one is left array. Okay, left array. And this is equal to, we have to create the array, right? So I'll say new int square brackets, and then I have to pass the length, that is n1. Okay, once this is done, the same thing has to be followed for creating the rightmost array. So let's say right array. Okay, again here there is new int and the length is n2. Clear? So once I have the length, so these are empty right now. There is no value, no data present, the actual data present. So now what I have to do, I have to fill this data into left array and right array. How can I fill the data? I have my original array in the form of ARR. Okay. So what I can do is I can iterate through my array and I can fill it based on the index value. So let's try to do that. So I can say for, let's use parentheses, int I equal to, let's say initially it is 0, semicolon I less than n1. Okay, semicolon I plus plus. Clear? Once this is done, now enter. Here I am going to say left array, which is initially blank. So left array square brackets my I. What is I? I is the index we can compare here, equal to, equal to my array. Now, what should we give here? We just can't give here I, okay? Because if we just give I, then this will be always like starting from what? The 0th index. Whatever is in the 0th place, that will be assigned to our left array. But that is not the case, right? We are getting, we should have the left array will be dynamic because it will be changing. So how is it changing? It is changing based on the left key. So here I am saying left plus I. Did you get a why I did left? If I didn't do here left, then what would be the array of I? This will give me the 0th index. But I don't want always my left array to have the 0th index. What should my left array have? What is the left point at present plus I. Okay, I'm not sure what will be the left point always. Okay, so the left point will keep on changing, and here plus I means from that point whatever it goes further. Okay, up to n1, so up to that length. Clear? Once I have done this, so the work of this for loop is completed. Similarly, I have to write the another for loop. So for in, let's say j, or we can use I itself, or let's choose j equal to 0, j less than n2. Okay, fine. J plus plus. Okay. Once we have done this, curly brackets, enter. Okay. So here also I have to fill my right array. So I can say right array of j, array of, now what should I say array of? Even here it is dynamic, right? Because what we are passing in our merge here, if you see, we are always passing our original array itself. So from this 7th line here, you can see the array which we are getting, we are always passing this. But whereas this left point and middle point are getting changed. How? Because here, if you see, we are changing our middle point. So here left and middle, these are getting changed, but the array is remaining same. So here we have to make sure that my right array, again, it is not like starting from 0. This should start from where? The middle. Okay, plus 1 plus j. Why plus 1? Because that's already taken in left array. Clear? Once clear, once this is done, I'll put a semicolon, and this completes our for loop. So enter. Okay, so now we have got our array. What we did here, we created our array. Okay, what we did here, we divided our entire array in the form of points. Here we are getting points. Here we got our original, we got our array itself. Okay, once this is done, now our task is to compare it. Okay, so let's try to compare it. So let's put my arrow here. Let me click enter. And here I'll create the pointers. Okay, these are these will act as an index. Okay, so I'll create a first pointer like I equal to 0. Then I can say j equal to 0 for right array. Then for my original array, I can say k equal to left. Okay, again why left? Because we can't give 0, because every time our array is not starting from 0. Okay. Once I have done this, now I have to sort it. So how can I sort it? Here I'm going to put a condition, that is a while loop condition. So while my I is less than, let's say I is less than n1. Okay, and j is less than n2. What is this? What is I? I is the index for the left array. What is n1? N1 is the length of left array. What is j? J is the index for right array. What is N2? N2 is the length for rightmost array. So here what we are writing here, it is nothing but in for loop what we have done here, right? So a simple iteration. Okay, these are separately iterating. Here we are trying to club the iteration. Okay, the condition here is same. Okay, now what I'm going to do is I'm going to enter inside this while loop. And here I'm going to compare now left array and right array. How can I compare? I can say if my left array square bracket, what is the index for left array? I. If this is less than or equal to my right array square brackets, what is the index for right array? J. Clear? So if this happens, what you do, go inside this curly brackets. Okay. And here try to update the original array, that is array of K. What is K? K is the index. Okay. And this is not from starting from 0. Okay. Make note, like K is starting from left. Whatever is the left point we are passing, for that particular point itself it is targeting. And that point will be equal to my left array of I. How come why left array of I? Because here we got compared and we got to know by left array of I, that is the present index value, is less than the right array index value. Clear? So once this is done, what I have to do is I have to update my I, that is index value. So I can say I plus plus. Clear? So once this is done, here I am going to write else statement. Okay. And in this, I'm going to do the same thing, but for right array. So right of K, that is K is what? K is the index for right array, should be equal to right of array. Clear? And here it will be J. Cool. So when will this else condition get hit? When the right array index value is greater than the left array index value. And what we have to do here, I have to update my J. So I can say J plus plus. Yeah. So once I have forgot to give the semicolon, let's give the semicolon here. I'll close the else. But if you note, I am not updating my K itself. K will remain same, right? So we have to update the K, no matter if it is the if condition is getting hit or else condition is getting hit. So for the both time we have to update. So I'm keeping it outside. So I can say K plus plus. Clear? So once this is done, this will complete our entire program. But there might be few cases when the left array is greater than the right array, or when right array is greater than the left array. Clear? There might happen few situations. So if like when we had drawn initially the tree diagram, if you see, like in one time it was having 7 and 15, and in the other way it was having just 2. Clear? So in such cases, what will happen is after even comparing, there will be few values that will be left out. So we have to club that values into our original array. And here we need not worry like if it is sorted or not, because the array which we are getting here is already in the sorted form. We have to just update it to our K. So like our original array. So here I can simply say while let's do I less than my N1. Okay. What is this? What is I? I is the index that is targeting my left array. N1 is targeting my length of this. So in case if the index is still remaining, that is in case it is still less, then go inside this. Okay. So then I'll update my array square of K value. Okay. Should be equal to left array of I. So I'm without even checking, I'm just directly updating my array of k because I already know that it is in sorted form. Okay. And then I have to update the index of both I plus plus as well as k plus plus. Okay. Similarly, in case if the right array is remaining, then I'm going to write while loop, while j less than n2 array of j right array of j. Clear? And here I am updating j plus plus semicolon and k plus plus semicolon. Clear? And at last I have to give a curly brackets. Okay, so our program is almost done. So let's try to put it to test. So let's go to this line where one, and let's append, enter, remove this. Here I'll call the, it's actually here. So, and then here I have to pass the array, comma, the zero starting position, comma, array dot length. Here. So once this is done, I'll close this. And after that, I'll again display the array. Display. Yeah. So let's try to check it. So I've compiled it and let's try to run it. So Java. Uh, might be some error due to which it is not getting compiled. So let's go here and check if what all errors we have. Here, while passing length, I have to pass -1. So insert -1. There is one more error here. It should be okay. So due to some XYZ reasons, it wasn't working on my NVim editor. Like there are few bugs. I have not yet installed the LSP, that is language server protocol, and the formatter in my NVim editor for Java. But yeah, so again, moving back to VS Code. So in case here, if you see here, it's working fine. So let me rerun it and show you. Okay, so if you see here, the original array, it's 12, 11, 13, 5, 6, 7, and here it is 5, 6, 7, 11, 12, 13. Here. Cool. Let's try to see how it's happening. Let's try to. Okay, so our main function started. We have created a array. This will just display the array. which is in the same format. Then we called our merge sort, where we gave the index value as 0. And the right is nothing but the rightmost value, that is array.length -1. So it's index value we are giving. So from here, where it goes to the line number 42. And here, if you see merge sort, it is we are receiving the array, then the 0, and here array.length -1. Clear? So here we said left is less than right. So if this condition is getting matched, go inside this. Clear? Initially, that is, this is 0, and this will be some values. Let's say for this 1, 2, 3, 4, 5, 6. So this 6 minus 1, it will be 5. So initially 0, 5. So this will always be true. But when we'll be dealing the calculation here, there might be few times where the value of this is increased and greater than the rightmost value. So in such scenarios, we have to avoid the merge sort thing. Clear? Okay, coming to this point. So if left is less than right, okay, it's less. Then here what we are going to do, we are going to find the middlemost element. Okay, so that is nothing but we'll find out this index most probably. And then we are going to call the function merge sort array left comma middle. So again, from here, it goes back here. But here, what will be the present left value? The left value will be still 0. But now the middle, it will be clear. And then again, it comes back here. It calculates the middle point. So the middle point now will be 1. Again, it goes back up. Okay, it goes back up. Then this time the middle value, like left value, is still 0. And if you see, the array is being constant, like it's being same. And here the rightmost value will be 1. Again, it comes down. Again, it repeats. And at this point, what it will get? It will get two separate elements. That is the 0th value and the 1. These are what? These are index. So whatever is the value in this, what is the value? That is 12 and 11. It got two separate values. Once it gets two separate values, then it goes back, like the call is being reversed, and then again it compares this. So this is again, you can draw a tree to get a brief idea how this is working here. Okay, this is the recursion that is happening here. Once you get such values, that is 12 and 11, how you are getting it? With the help of index. Once you get these values, which are important, 0 and 1, these values are being passed where? You are being passed for, let's say, array. You are going to pass, let's say, here 0, and here you are going to pass middle as it is 1. The right at that time, whatever it is, that value will be passed. So in case if it was the first time when we are passing, let's do it for first time. So first time it was 0, here it was 5. And here you will be calculating the middle value as 2. So the first time when we are going to call this function, then that time it will be somewhat like 0, 2, 5. Okay, we can't guarantee that this is the first time that is being called, because in recursion, it will keep on changing. Like if you draw the tree, then whatever the value you are getting in the bottom of the tree, that is the one which is going to be called for the first time. Clear? So in this way, we are like, in simple terms, we are passing the values here. That is 0, and the middle value will be, let's say, anything like 2, and let's say 5, some values we are passing. So from here, where it goes, the merge, it comes back to this line. Here we are receiving the array, our leftmost point, middle point, right point. What we are doing in these two lines, here we are nothing but we are calculating the array length. Okay, and whatever is the length of that length, we are creating a array, two new arrays, that will be one left array and right array. And then what we are doing here is we are filling our left array as well as we are filling our right array. How are we filling here? So if you notice here we are saying left plus I. So here left was, let's say, 0. So from here plus I we are going to do. Here middle was what? Middle we had passed, like we had discussed, we are passing 2. So from 2 plus 1, that will be 3. 3 plus j. J is nothing but the length, like it will keep on repeating. So this value 5, 6, 7 is being added here. Okay. So in this way, we get the left array as well as the right array. Once we get our left array and right array, which are in now in sorted form. Okay, they are in now in sorted form. How they are in sorted form? Because this is being called, like this entire thing, which is a recursive function. Like this function merge, sort, and merge, they are continuously being called again and again. So whenever you get one element, right, when it updates back, so they both are in sorted form. It's clear. So once this is done, now what is happening here? We are creating, let's say, here we have left array, right? So let's say the left array is of 2 brackets, the right array is of 3 brackets, and our total array will be of, let's say, 1 2 3 4 5 6, 1 2 3 4 5, and one more here, 6. Clear? Now what we are doing here we are just comparing which is greater. Like in this, like which one is lesser. The item which is lesser, that will be added here. So let's say, and this is not like we are always starting from the 0th index. If you see here, I have written left. Okay, so whatever is the leftmost value, so from that we are going to start it. Okay, then what happens is that we are comparing the values from this. So after comparing, let's say we have filled the 4 values. After filling the 4 values, there is always one element empty. Or let's say if there was one more here, okay, one more bracket. So right array had, let's say, 4 elements, and there are 2 places which are empty. Now I already know this right array is in sorted form, so I am just going to directly place these 2 in my original array. How I am going to do this? For this, there is a logic that is written here. If there are any extra pieces, follow this. If there are no extra pieces, like if it was just 2 and 2 arrays, then only till here our program could end. And again, if there are any callback functions which are left, it would have repeated the logic. In this way, it keeps on running again and again, and at final, we are getting a merge sort. Clear? Just a simple thing. Try to see what we have done here. This is the part where we are breaking the arrays like into small parts. How we are breaking it? In the form of pointers. We have the left and right pointers. Then this is the function which is going to club it. And when you have reached this point, this already assumes that this your merge sort has already sorted it. How is it sorted? Because when it has broken, like when it keeps on recursively calling here, there is a point where it gets just one element. Okay, when this one element it has received, that time when it calls the merge method, these 1 elements have been passed here. Okay, let's say one element have been passed, and here after all the logic, the array is updated, which is now in sorted. So these 2 are sorted, and these are directly updated to our original array. Okay, so after doing this, when it goes back to this part, and now let's say it has 2 arrays like this. Clear? Okay, now this 2 it got from here. Okay, which just sorted and it gave it back. And this is from a different branch we are getting from here with the help of recursion. Now these 2 are passed. So this is the left array and this is the right array. These 2 are being passed to this thing. Clear? It may sound confusing, but the only trick here or the way to understand is that keep this separate part. Try to apply the recursion logic here. Try to think of a box here, okay, which is just going to break the elements into separate points. Just try to think that. And this is a separate game here. What is this doing? This is just going to assume, like here you can just assume that you already have a function which is going to give you the sorted arrays, and here you can apply that logic. Okay, if you try to compare this is very easy. Like here, nothing is happening. This is the recursive thing, which might get confusing, like how this is actually happening. But yeah, I guess I tried my best. to explain it. Okay, cool.